Hello. Okay. Good evening, everyone. Could I get a quick show of hands who here has ridden in a autonomous vehicle before? Maybe Waymo or using autopilot in Tesla? Cool. I'm deeply interested in the autonomous and robo-taxi space because I believe that one day most of us won't be driving cars and even fewer will own them. Not just because it's more convenient, but because it can fundamentally improve safety, reduce traffic, and also reshape how our cities may work. It's a vision that we've seen for decades in sci-fi films, and what excites me most is that it's no longer just fiction. Our guest speaker today is Forrest Iandola. He's a Cal alum who earned his PhD right here, focusing on deep learning, not just studying groundbreaking AI, but also building a company and bringing it to the real world. Forrest co-founded DeepScale, a startup that pioneered the neural networks like SqueezeNet, which focused on allowing powerful AI to run on limited, low-powered hardware, which at the time, most of the field was focusing on bigger and more power-hungry models. In 2019, Tesla acquired DeepScale as part of their full self-driving vision-only push. So what sets Forrest apart is that he doesn't just live in the lab, and he focuses on things outside the lab too. He's a self-described track rat where he spends his weekend racing his rebuilt electric vehicle called the Electric Turtle, competing in the 24-hour Lemon, not to confuse you with the Le Mans. He also did a TED Talk where he predicted a bunch of AI things that became into reality. Today he's a research scientist at Meta AI, where he sits at a rare intersection between academic research, entrepreneurship, and real-world deployment. Please join me in welcoming Forrest Iandola.
Handing off. I'm going to have you sit over here, Forrest, if you don't mind. Paul, I just want to recognize you. Are you here for the semester? For the year? For the semester? Just for the semester. And you are going totally outside your comfort zone. I asked you last week to introduce Forrest because you indicated that you were interested. You did a phenomenal job. You memorized it. You are memorable. I just want to give you a special shout out. Let's give him a hand. So nice to see you.
I'm back.
You are back. How does it feel?
It's good. It's not like 30 degrees cooler than the rest of the Bay Area, like usual Berkeley winter. So
it's beautiful tonight.
Yeah,
I was thinking maybe we should do a sunset picture, but I don't know if it's going to be too late or not.
Yeah, maybe we should have had class outside.
That's great. Then you would just need to invent a way for us to easily have the screen and the wireless outside. Can you do that?
Maybe.
I like you even thinking about it. So, last week when we started class, I told the students what I consider to be a little bit of secret. Sometimes when you're trying to get people's attention, it's easiest if you talk about them. And so I thought we'd give an opportunity to do that with your question that you had for them. Forrest asked this question. I think about 60, it's fine, 60 of you in the class answered it. And that's, I'll let you ask the question.
Yeah, for those who can't see or don't feel like reading it, if success were guaranteed, what would you work on?
You are welcome to raise your hands if you don't see your answer up here. But Forrest, I know it's kind of awkward to look in the back of us, but these are some of the answers people had. I thought race car driving was so apropos, since Paul also mentioned that, or racing, music, singing, dancing. Things that have to do with funding new ventures, doing a startup, investing in AI venture, land, food sovereignty, universal health care. I really like this one, cell regeneration pods, probably because I'm older. Patient care versus health care, animal rescue, dog hotel, addressing housing or the crisis, poverty crisis, neuro-inclusive employment, also a really interesting one. Food naming, it's always a good one. Aviation, doing a bookshop. Microbiome, I think working on the microbiome. Improving teachers. I liked not improving teaching, but improving teachers, always important. A dinner club, social club. I think there's also a fitness club. Working on a fashion brand. Public speaking. Working on yourself or helping others. So there you go. Does anybody want to add something that they think is pretty unique that they want to work on? And we'll get the microphones around because Claire and Bobby need, they're getting warmed up. If you have something interesting, this is your opportunity. What do you think about those?
They're pretty good.
Did-
I like the diversity of people's interests. I feel if you go to a certain school on the other side of the bay, they'll all just say, found a large language model startup.
There you go. Thanks.
So, good that you're not losing track of what matters to you personally.
Why did you want to ask that question? Is it because you want people to be like in tune with what matters to them personally?
Yeah, I mean, I think it's really easy to get kind of sucked into chasing the next opportunity, you know, get an A in the next class, get that internship, get that job, get that promotion. And the more time you spend doing that, the more time you then continue to spend doing that. Nothing wrong with it. I think we should all probably do that at some point in our life. But taking a step back and going, you know, what's the delta between the world as it exists today and the world as I would prefer it to exist? I think if we all do that and we sometimes act on it, we'll probably be very satisfied in our work.
You seem like a person who does that a lot. Do you take time to do that? Is that some part of your regular life process that you kind of step back a little?
Yeah, I feel whenever I'm in a rut or trying to decide what to do next, I try to think that way. And it certainly helps. I think you'd think the time would be most helpful is like, oh, beginning of the year, beginning of the semester, transition to a new role. What do I really care about? That's kind of, I feel, a time where I'm not very productive at this question. Where I'm really productive at this question is when everything's going wrong and my current project feels pointless, or it feels impossible, or the people I'm working with, we're not getting along. And I take a step back and go, is this all worth it? Or what would I rather do? And like when I'm in that kind of grumpy mode, that's when these ideas of what I'd rather be doing really bubble up the most.
I love hearing that. Well, we're going to talk about maybe when you're in various modes, but I love how you started at Urbana, Illinois. You still have that telephone number. I like how you were like loyal to that. Very nice. Is anybody else from Illinois in the room? Do we have any Illinois? Any Chicago represented?
Has anybody heard of Illinois?
What is it like there?
Good
Well,
question.
I should ask.
How much do you want to know?
Why'd you come to Berkeley instead of staying there?
Yeah, I mean, for those of you who have been to the Midwest, I think the differences are pretty self-evident. The weather definitely has more flavors, but I think the bigger thing is in the Bay Area, I feel the average person you meet is much more aggressively pursuing some goal and also maybe struggling more with just the cost of keeping up with living here. So I think the Midwest tends to be a little bit more relaxed, slow pace of life, with the trade-off being if you want to do something, you know, really pushing the envelope at an aggressive pace, you won't necessarily find as many peers who are kind of in the same mood to do that.
So, I mean, people talk about different Silicon Valleys, like starting things up in different places, but it sounds like this is still it for you, this area.
It's great. I mean, I think especially if you do go the entrepreneurial route, or you just want to work in a career where you do try to make rapid progress, whether it's, you know, kind of rising, you know, in the company or rising in your field, I think this is a great place to find lots of mentors, friends, investors, coworkers who are in the same kind of mindset. I think once you've built a little bit of that in terms of your network as well as your ability to kind of like have that discipline, then your choice of location, I think, starts to matter a lot less. I think it's way easier to go back to where you're from, or go to some place you're interested in, or someplace that has some opportunity and chase that, and still have kind of the Silicon Valley mindset to fall back on no matter where you are.
I like that. Can you take us back to, I mean, how old were you when you got to Cal?
Sure, yeah, I got here when I think I was 22 probably, maybe 23, and yeah, 22. And you know, I guess maybe I'm jumping ahead. One question you wanted to ask is why did I come here to begin with, right? And so maybe I have to go all the way back to why I majored in computer science at UIUC. So let me kind of briefly tell you the answer to that. So I knew I wanted to be some kind of an engineer. I mean, some of us figure it out. Some of us are kind of born knowing that, I suppose. I like making stuff. And I thought I wanted to be a mechanical engineer at first because as you'll hear later, I like cars and transportation and you know, the world of actually building things that move. But once I got to UIUC, I was in for a bit of a rude awakening. The computer science building and the mechanical engineering building were like two different worlds. Much more so than at Cal, I think. I think the mechanical engineering building was kind of like full of bright people and good ideas, but it was like this kind of crumbling bricks and you know, kind of stone masonry building. Always too hot or too cold, pipes clanking, you know, it seems like you're always in the basement for some reason. And you go over to the CS building and it's like, wow, this feels like an above average tech company building. Like a lot of big windows, seems like it's always the right temperature. Everything felt pretty new. The lecture halls had like office chairs, which I thought was a nice upgrade, instead of like those ones that fold down, you know,
Like the ones we're sitting on?
even worse, like from the 1940s or something, you know.
The wooden ones.
Yeah, something like that. And so, you know, I already knew a little bit about computer programming, and I happened to get a job helping out with the website of the UIUC CS department, like, you know, just for their web presence. And so I was spending a lot of time over there, and I was like, you know, this just seems like a welcoming place to work on cool stuff. And you know, I walked outside and looked at the name of the building. It said Siebel Center for Computer Science. So I figured out who Siebel is. So he had a couple of pretty good startups. And mechanical place, I'm not sure who that was named for, but I'm sorry for whoever it is. Anyways, so, you know, I just kind of felt like the CS thing, you know, if I could be any kind of engineer, why don't I start with the one that really seems profitable? And so I went down this path. And coming out of undergrad, you know, I was pretty sure I wanted to do some kind of startup based on technology. But where I felt different from my peers was the other students who were doing startups straight out of undergrad in CS seemed kind of fixated on things like, let's build an iPhone app for something we used to do on the computer. This was maybe 2011, something like that. And like that was a reasonable thing to do. I think some of them actually did pretty well in that business. But other than maybe some of the user interface challenges of moving to a smaller screen or a touch screen, it didn't seem like a very compelling technical problem to me for the most part. And so I wanted to do something where we really have to solve some challenging problems, but in exchange for that, we get to build a product that nobody's built before. And I thought doing a PhD would be a good way to both get some experience building, you know, more advanced technologies, and also just to build a network of people and friends who kind of want to do the same thing. And so I applied to a bunch of places. I applied to UIUC for PhD. I also applied to Cal, Stanford, also Davis and Santa Cruz. And that was it. Like if I didn't get in, I was just going to go work somewhere for a year and try again. I was kind of done with the snow at that point. And I somehow managed to scrape my way into all of them. And I chose this over the alternatives largely because of the people. So when I visited the CS department, the professors were kind of all working together. They'd form these groups of several professors in their faculty and solve big problems. And I thought that sounded more fun than kind of a more siloed experience. And so that's why I went down this path.
How did you how did you start meeting people? How did you start reaching out to the professors?
I think it was pretty easy. I think before, look, I don't know how it works today, at least at this time, this was about 2012, you would apply, and then if you get in, they would invite you to come out to campus and meet people for a weekend. And so I met a bunch of people there and started to see who might be good to work with. And then once I got to campus, I learned more, and I pretty quickly chose an advisor, which I can talk about later. But I think meeting people here was always pretty easy. I mean, people like to talk about their ideas and their research, and that was never a big problem.
Is there anything like looking back on your like 22-year-old self, you would kind of say like what do you wish you'd done more of, or what would you recommend for students to do now as they're thinking about things?
I would say I don't want to like take that guy and send him in some totally other random direction. I would maybe make some minor tweaks. I think I was actually very disciplined in doing work. I think I was good at finding problems to work on. I think where I wish I had done a little bit more is just kind of spending time with people in our field not talking about research and just going for a hike or going to a concert or something. I think I discounted the value of that to some extent. I just wanted to grind out a little bit more progress. And later on, when it came time to recruit for my startup, I felt, well, having been at Cal for 4.5 years, I know more people than I would otherwise. But if I had really maybe on the weekends engaged with people, I probably would have much tighter connections of people I could kind of recruit or try to collaborate with.
I mean, just in case y'all are wondering, 4.5 years is kind of unheard of to get your PhD, unless you know something different than I do. I mean, it's pretty unusual.
Statistically, it's not that far adrift. I just feel like a lot of people set like 5 years is like the goal, and then maybe it slips a little bit from that.
You also did these incredible internships. You did them when you're in college, when you're undergrad, and also when you're getting your PhD with companies that we hear about a lot. In fact, in 2 weeks, somebody from Microsoft is coming, and in I think 6 weeks, someone from NVIDIA. How did you get those internships? State Farm, not quite as sexy, but I think that was when you were in Indiana. But Lawrence Livermore National Labs, also, I think, if I'm reading my acronym right. How did those come about?
So I think I had different strategies for choosing internships when I was an undergrad versus grad school. I think for most of them, I was more prioritizing research over working on products. I figured I could always do products later, and in some of the startup ideas I was tinkering with, of course we were looking at products. And the reason for kind of aiming for the national labs in undergrad, I did 3 internships in national labs, a little bit in high school, and then in college. I was at Fermilab, I was at Lawrence Livermore, and I was at SLAC, used to be called Stanford Linear Accelerator Center. The reason I didn't go to companies and I went to those government internships was because it was actually, at the time, easier to publish papers. And I wanted to both build some experience and also build some track record doing publishable research. I wanted to see if I liked that, and I also knew that to get into grad school, it would really help if I had a few papers. And so before I actually accepted each of those internships, especially the SLAC one and the Livermore one, I kind of talked to them and said, hey, like this is what I'm looking to do. I'm trying to pursue a PhD. I want to collaborate on research with you. Can we write papers together? And only kind of like when I understood the answer was yes, I took the job. And they did pay somewhat worse than working at Google or Microsoft or something, but the trade for me was worth it. And then once I got to grad school, when I did internships, it was more expected that you would work on research and publish papers and maybe release some code and things like this. And so in grad school, I could kind of do whatever I felt like and still do that. So Microsoft Research was a place I did that. One other one, I occasionally run the counterfactual of if I had, so NVIDIA was the summer between undergrad and grad school. And if I had just stayed, that might have been pretty profitable. But I always check myself on these things. But I asked myself, could I have predicted that? There are lots of companies I could have joined, things I could have invested in that went up. But I asked myself, honestly, was there something I could have seen at that time? And I think the answer for me with NVIDIA in 2012 was no, not really. I think it was a niche company doing computer graphics, primarily for gamers, a little bit for 3D modeling. And I had no idea that it was going to do what it ended up doing.
I mean, they've been around since the 90s.
Yeah, exactly. It was worth, I did the math, it was worth 400 times less than it is now.
That's kind of incredible.
Yeah.
One, believe it or not, I think we're on almost the 10-year anniversary of your PhD.
Yeah, it'll be the end of this year.
Do you think it was worth doing?
Yeah, definitely. And I have a couple different things to say about that. One is for me personally, I think really building that experience of how to spend a long time on a particular problem, how to pick problems that are worth spending a long time on, and also having a PhD advisor who's not just trying to get me to crank out the next product and make some money for the company, but really wants me to personally succeed. I wish I had that. I wish I had all 3 of those things just available to me all the time for the rest of my life, right? Those were great. I think where it also worked well for me is I like being fairly self-directed and just I can kind of survey the landscape and sort of see what's interesting to work on and what would be beneficial for other people and then start digging into those problems. I think if you have that, a PhD might help you get better at that, and if you don't, it'll help you get started. So I'm pretty pro PhD. The other thing I would say, at least in the AI field, the way things have evolved, 10 years ago, I don't feel like AI PhDs necessarily ran Silicon Valley. It was more like we were just like one of the many subspecies floating around that were available to work with. But now in the era of like OpenAI and Claude and all these things are super popular and worth huge money and are all based on kind of like PhD level AI technology, I do feel like PhDs have like, you know, it's like, it's not like as, how do I put it? It's really a way to kind of parachute in to one of these companies or start your own on a much different playing field than not having done a PhD or not having done some kind of significant research in that area.
Yeah. It's, I'm going to give you all a little insight. I've got a list of questions here. Forrest was supposed to speak next week, but we decided to shift. I wanted to highlight how incredibly adaptable you are. I don't know. I would think maybe you wouldn't. And not only are you busy at Meta, that small company, doing AI stuff, but also looking at questions, thinking about what we show you all today. I just kind of wanted to give you a little bit of insight into Forrest. Kind of, we talked a little bit about Forrest's background. We're going to go now into his company experience, but I just wanted you to know that he is an unusual, I would say you're an unusual individual, and that you were flexible on when you came, based on when Kurt's coming, who's your, I think you're going to talk about as your advisor, and also the attention that you gave into the slides that we're going to be showing. And so I just have to make sure that what I'm going to next, yeah, there you are in Indiana, and there you are winning already. I don't know if you can, I know this is a little bit fuzzy.
You want me to tell you what this is?
Yeah, tell us what that is.
Yeah, so this was these were both in UIUC. As an undergrad, I got involved in scientific conferences and writing papers and things. So I think the one on the left is me presenting some paper, and the one on the right is I was part of a team that tried to improve the speed of some computer science benchmarks, like the top 500 benchmark. If you know what the top 500 is, it's pretty obscure now, but back then it was like a benchmark both for your programming skills and on a distributed computer and your ability to build a good distributed computer. And in UIUC, we had made some progress there, so we won a little award.
I think the next slides are on, oh, wait, no, not quite. SqueezeNet. Do you want to talk about this a little bit and about your lab work?
Yeah. Did I change this and you have no idea what's here anymore?
No, well, maybe.
Yeah, I know people do that to me sometimes, so
it's okay.
Yeah, payback.
We're here. We're fairly relaxed. There's Kurt Kortzer. I like it. Khalid. Yeah.
Yeah. Well, maybe what I should, while this is up, what I should say is, so when you asked me whether PhD was worth it, I just talked about kind of the procedural aspects of it, of, well, you get to work on the problem for a long time, you meet cool people, like that. I didn't talk about the impact of the work. So I spent most of my time when I was doing research on trying to make AI run faster. And this was an area that when I started was pretty obscure, and by the time I graduated, I think became much more mainstream. And I think it was for a combination of reasons. One was that AI models were getting better, more and more people were making progress on the accuracy. And so naturally you need some other people, and I was kind of one of the first people to kind of show up for this, to compress them and make them fit in a compute footprint that's practical. And so we wrote probably 10 plus papers on various elements of this problem, but the one that really got some traction externally was SqueezeNet. I think this now has over 12,000 citations. And I think we got a few things right. One was we picked a benchmark. We picked ImageNet, which is still a somewhat popular computer vision benchmark. We looked at the models that people were commonly using on ImageNet, which were all, for the most part, pretty computationally expensive relative to the compute available at the time. And then we tried to figure out methods for reducing the compute cost. And we did early versions of neural architecture search, where you try many different models and look for something good. We found parts of the model that you could kind of delete, ones that you could kind of reshape. And then we put it out in the open and broadcast it somewhat heavily. So put it on GitHub, posted on Twitter, kind of shared it with a few people. And somehow it just kind of struck the right chord. So within like a week of releasing it, several people had picked up the code and like retrained it on their data for other AI problems. People had taken it from the framework that we were using at the time, Cafe. I know I'm really old. We were using Cafe, and ported it to other ones that were also really old now. But people were kind of just pulling it into their code base and starting to iterate on it because it solved the real problem that they have in terms of the model size and the computational costs of AI.
Yeah. I mean, whether or not you understand everything that Forrest just said, which I don't, by the way, I'll just be like, open about it. But what you did say is that you iterated on it. You put something out there. It didn't have to be perfect, but you put it out there and people started using it. And I think that is a lot about what next level innovation is about. You just start iterating on it. And then suddenly you're working in the lab and you're starting deep scale. Would you mind telling us a little bit about that?
Yeah, so I guess I should introduce this character who you'll meet next week, Kurt Koitzer, because he's highly relevant to this, highly key to the story. So
he's right in the middle in the back row.
Yeah, that's
with
right,
a beard,
next to me. Yeah.
white beard.
So Kurt is, I would say, he claims to be a professor. I would say he's principally an entrepreneur who is pretty good at also being a professor. And he's done a lot of startup investments over the years. He was early at a company called Synopsys, which is now one of the standard vendors of tools for designing chips.
Do you know that Rich Newton, who the speaker series is named
Of course.
after, hired him to
Yeah,
Cal?
I know
Yeah.
that story. Yeah. So anyway, I chose pretty early in my PhD, I chose Kurt as my advisor because we both cared about speeding up AI and we both cared about doing a startup. And so kind of the whole time I was here, Kurt and I would riff on different ideas of how we could build products that use AI. And we had lots of bad ideas. I think we had a couple of okay ideas and a couple of good ideas. And I think we just tried to listen as much to potential customers as we could. We didn't, some people when they start a company, and a perfectly valid thing to do is to really set a vision for what this all should be and who's going to use it and then build all the stuff and then kind of like later on find out if it was right. We were much more like, let's try to build some like simple demos and show customers or, talk to potential customers and show them like even the papers we've written and the potential of how we could adapt that into a product for them. And the people who really came out of the woodwork the most with interest in our capabilities were in the automotive space, which was great for me because remember I'm like the guy who opted out of mechanical engineering because I just wasn't brave enough, to brave the cold in that building. And I'm like, finally I can work on cars again, right? Like this is great. So I start finding opportunities to help people with autonomous driving and also driver assistance. So in driver assistance, I mean more like keeping the car in the lane, don't crash into other things, but the human still is pretty involved in the driving. And we were getting more and more people showing up to our discussions saying, hey, I've got this autonomous car prototype with like the trunk full of GPUs and this is cool, but I can't sell this. I mean, this is not ideal. And so we started looking at what are the different AI problems that these companies have. Can we build some standard model architectures that would solve them? Can we collaborate with the companies in building the data sets? And that's kind of where the company DeepScale that we started came from is just trying to figure out how could we help the automotive industry with basically with two problems. One is taking full autonomy and reducing the compute cost, and these are already based on neural networks typically, on deep learning. And then the other problem area was for people who are working on collision avoidance and more basic driver assistance, can we take the traditional solutions they have that run on very small hardware but are not deep learning yet, this is like 2015, and get deep learning to fit on these tiny chips that they have. And it was actually the second one, helping more people with commodity cars squeeze deep learning onto the chips they had was where we got the most, that's where we spent the most of our time.
How did you, where were you and who are all these people?
Yeah, at our peak we had about 30 or 35 people in the company. So a lot of these folks are engineers, some are in the business side, things like that. And this picture was taken in our office that we had for about 3 years in Mountain View, just surrounded by Google buildings, basically.
Wow. And suddenly you had somebody interested in acquiring you, or maybe multiple people interested in acquiring you. How does that come about?
Yeah, so I think it's not as mysterious as it sounds. So we would talk to car companies about them using our technology in cars they actually build and sell. And we did make quite a bit of progress in that direction, like putting together developer kits that have our models that car companies can try, and iterating with them on improving the quality and all that. But a lot of these discussions would head down the path of, hey, this is great tech, but we internally also want to be an AI company of some sort here at whatever car company. And if you could just continue building that here and we could kind of like absorb the people and the IP, that would actually be more convenient for the big company because we could just collaborate openly. There wouldn't be kind of like NDAs and all these things standing between us. So this conversation came up a lot, and for quite a while I would just try to steer it back into, okay, but we're building a product, can we make the product suitable for you? And parallel to working with customers and building the product, we were raising venture capital money. So we raised a pre-seed round, and then a seed round, and then a Series A with gradually higher valuations and amounts of money. And when it came time to raise our Series B, it was a little bit trickier than the other funding had been because we still hadn't gotten to the point where car companies were actually shipping cars with our tech in it. And we didn't really have big purchase orders yet either of cars to buy lots and lots of units of our software. And so we're like, okay, we're looking at doing a Series B round. We're not going to get a huge boost in valuation because even though our tech is a lot better, our business progress is not doesn't look huge since our last fundraising. And so then we started to take the acquisition discussions more seriously with the car companies we were talking to, and we ended up taking one of those.
I remember when you were at Tesla.
Uh-huh.
I think I called you. And I don't know if we're allowed to say this or not, but I'm going to say it because we can always edit stuff out. You didn't seem really happy.
Yeah.
And I read, by the way, that the reason why Tesla bought DeepScale was because of you. Oop, I don't have it in there. Yep.
Yeah, I think. Let me just talk about what Tesla was like. I think one of the top questions I get when people hear I worked at Tesla is, what was it like? What was the work-life balance? Was it 996? Did you meet Elon? I can answer those rapid fire. Was it 996? Not exactly, but the joke is you could work from home on weekends if you want.
Oh my.
I did have a meeting with Elon every 2 weeks or so, not a one-on-one, but like 20 or 30 engineers who were working on Autopilot and FSD would like meet him for half an hour or something, plus 2 bodyguards in the background. I just want to make sure they get credit for having shown up to all those meetings.
Wait, why? Who were the bodyguards for?
Probably not me. No, Elon was pretty in the open in the office, but there were these kind of like people following around, like one person taking notes and other people like protecting him. Maybe, I don't know what they did. But anyway, I would say the good thing about working at Tesla, at least in those days, was you have probably the biggest data set of autonomous driving data available. And you can do a lot with it. It wasn't like some other companies where you have to like spend forever telling the lawyers what you're going to do, and then you might get to do it. You could just kind of do stuff. I think, and then the caliber of people was very high. I think a lot of people didn't stay super long, but people kind of were candles that I think burn fast and bright there typically. I think the most difficult aspect of it, besides just the pressure of having to deliver much more quickly than most companies, was I didn't feel like we had a culture of being straightforward with our customers. There were a lot of like really big promises that nobody internally really thought were possible to deliver on. And this was one of those times where I kind of looked myself in the eye in the mirror and thought about like, why am I, like, every day I'm doing this balance of like, what can I actually accomplish in the project versus what do I have to kind of like claim to be doing, or at least not disagree with the idea I might be able to do. And that eventually, I think, got to be too much, not just for me, but I think for a lot of us.
We have about 10 minutes, and I'm going to skip over a little bit. I'm going to skip over Iandola a little bit, but it seems to me that often you've taken a step back, and we're like, oh, wait, hold on. What's my mission? What do I really want to do? Doing that often. Do I feel like I'm doing the right thing? You have a moral compass in how you're doing things, and it's actually refreshing. But I also find it interesting that now you find yourself at Meta. And I know that I'm jumping forward a little bit, but Meta, like for any other like reason, like Facebook, people were not that cool on Facebook, and maybe Meta is better. But I am curious, how you then came to Meta, and I wanted to talk a little bit about Meta before we open it up for some questions.
Yeah, sounds great. I think, so once I got tired of Tesla, I took some time off, and then I joined a startup called Iandola. I just want to tell a little bit so I can get
That's
to
fine.
it.
I have to ask you one question on it.
Yeah, tell me.
So you didn't have a contract where you had to stay there a certain amount of time?
California is pretty relaxed with
Okay,
these things.
just wondering.
Yeah,
Okay.
yeah. It would have been better financially if I had, I mean, but that's true of any job, right?
All right.
Yeah. So I just want to briefly explain what my next job was when I explain why I went to Meta. Maybe it's a little bit rambly. But so when I left Tesla, I wanted to keep doing something with robotics. And I'd consider autonomous driving to be a type of robotics. And so I worked at basically a robotics startup for about 1.5 years. And what was good about it was, it matched my skills. The work actually was less challenging than what I'd done before. In fact, some of the projects we were working on, with drones and so forth, were so much easier than self-driving. I mean, there's not a lot of hit in the air with drones. So they were so much easier that we kind of would just download the recent paper from NeurIPS or CVPR or whatever AI conference and train it on our data, and we put it in the product, and that was kind of like, okay, done, on to the next thing. And I eventually got bored with that and wanted to solve slightly harder problems again. And I looked at where a lot of my PhD colleagues had gone, and a lot of them either were at a place like like Meta in a research role or Google in a research role, or had gone through there at some point, and typically had good things to say about it. And so I decided I would give it a try. And the question I used to always get is, you want to jump to Meta if you want, unless you want to linger on this. The question I used to always get, are you in FAIR? FAIR is Facebook AI Research, or I guess now it's Fundamental AI Research because they rebranded to Meta. And I was never in FAIR. I was always in a group called Reality Labs, which does like the AR and VR stuff, and also has a lot of researchers in its own right. I never get asked about FAIR anymore. Everyone now asks me if I'm working on super intelligence, which I'm lucky if I'm working on regular intelligence, to be honest.
How did it even come about? Did you approach other people who were working there? Did they reach out to you?
Well, something you're going to hear a lot throughout the semester is this phrase that I used to roll my eyes, and now I go, oh, it's so true, is it's a small valley, right? Like people just kind of start to know each other. And so it was like, I think the manager I've had for the whole time I've been at Meta, it's been like 3-point-something years now, he was involved in sponsoring our research at Berkeley like several years earlier.
Yeah.
And all of us were interested in the efficient AI problems, which are pretty important for like these mobile devices that Meta makes. And so yeah, it was just like, in a small community, it was kind of obvious who are people you should talk to.
So even in a classroom like this, we focus a lot on connections, but it is amazing. So I told you that, and Nicole Reddy is also going to come speak, who from Andorra also.
Yeah, he's great.
Which is funny. Tell us what you're working on at Meta, and what was fun is when we talked recently, you were telling me about how you get your ideas brought up and worked on at Meta.
Yeah, so it took me a while to figure out what are the constraints of doing a new project in not just Meta, but kind of like a research organization in a big company, or an applied research organization in a big company. And it's a little bit different from PhD or startup. I think PhD or startup are easy to write on like a sticky note. Like PhD, it's like, something on the order of like, do something good for the world and be novel and get conference papers, right? Something like this. You can do other things, but like that's what you're graded on. I think for a startup, it's like some combination of get hype and make money and also raise money. And everything else you do is like, you can do it, but you have to do these things typically. I think in applied research in a big company, it's like a more multi-dimensional problem. Like there are more committees, more debates. But if you try to collapse all that into something simply read in a sticky note, it's like, okay, what are problems that the products currently have, or you think you can explain why they will have these problems in a few years? And if you can explain that well, and you can explain how you might solve it, you can reasonably expect that you could create a new project, at least enough of a project for you yourself to work on for a few months. And then if you can kind of like demonstrate some value, some results, then you start to get other people kind of excited about it, and other people kind of like, maybe managers start sending you their engineers to take a look, or maybe people voluntarily try to get involved.
Are you allowed to give us any examples of what you've done?
Yeah, my most recent one, I I want to come back next year and talk about it.
Okay.
But I think I can tell you a different one that I also like. So I would say recently a lot of the work in the group I'm in is kind of more on the wearable device side, like these.
Does anybody have the the Meta glasses? Sorry, didn't mean to say that.
Yeah.
The Meta glasses. Does anybody have some? Yeah. Oh, you guys too? Wow. Anybody else? It seems to be like this side of the room is very Meta glasses. Okay.
Yeah. So, but I'll talk about one that's maybe like from kind of like the last development cycle, I would say, from the VR side. So, does anybody work on computer graphics at all? No? Does anybody work on mechanical stuff? A few people?
One person in the
Yeah.
middle.
Cool. Okay. So I would say there's like a problem at the intersection of maybe human mechanics and like body mechanics and computer graphics that a bunch of people in Meta are working on. And it's making really high quality avatars to use inside VR virtual worlds. They don't just want avatars that look kind of like you. They want you to like do a quick scan of yourself with your phone camera and then have a super accurate avatar that looks exactly like you. This has like been a big vision for the company for a while. And what happens a lot is there will be a big leap forward in computer graphics technology, and then people will scramble to figure out, first, can we apply it to avatars? And second, can we get it all running in a budget where we can do a lot of the rendering of that avatar, as well as any like real-time AI that we need on the headset itself. And so I was working in this area for maybe a year and a half. And the most exciting time in it was there was this technology that came out a couple of years ago at SIGGRAPH. I don't know if people know what SIGGRAPH is. It's a big computer graphics conference, kind of like the top one, called Gaussian splatting. And Gaussian splatting, like, it's not meshes or textures, it's not nerfs, it's just like a different way of doing graphics. And it works a lot better. It has a good compromise between it's reasonably efficient to render it in real time, but it's a good representation to take a bunch of data and have machine learning train a model, whereas like the more classical graphics approaches are harder to make machine learning train a model of your object. And so where I found myself in the summer of let's say spring of 2024 was Gaussian splatting was, to me, pretty clearly the future of the problem that we were working on, but only a few people in the company were doing anything about it. At least that's what it seemed like then. And so I was like, this is such a different way of doing graphics. I've always wanted to be a computer graphics person, at least a little bit. So a great time to enter a field is when it's all changing and the old knowledge is like a little bit stale, you know? And so I was like, let me just become a Gaussian splatting expert. And so I spent like a month like studying all the details of it. And I put together a lecture like demystifying Gaussian splatting because like the papers and stuff on it were super confusing. And I was like, actually, there's like 5 pictures you can look at to understand how this works. Now this video has like a lot of views on YouTube, I guess. But anyway, I did that, and I showed it to people around the company, and I presented it at a conference, and then all of a sudden, like, everyone's coming in with their Gaussian splatting problems.
And that's the TED Talk you did?
That's another one. The
okay,
TED Talk was, like, earlier.
Okay.
Yeah, this was just a tutorial at CVPR. Yeah. And anyway, so I kind of, a thing I like to do is, like, to just pick a new area and then just immerse myself in it and, like, make so much noise while I learn how it works that people kind of notice my existence. And then I did that, and then the people I've been working with on avatars, you know, we start looking at how to use Gaussian splatting, and find that while on like a huge GPU that you would have under your desk, it's fast enough. On a VR headset, it's like absurdly slow at that time, and so we have to figure out how to fix that. And I'm like, okay, great. Like I know like the efficiency stuff pretty well, like how to make efficient AI, and I study Gaussian splatting a lot, and so I just start trying things, and then eventually more and more people are interested in it and all have like, you know, wildly different ideas for what to do. And so I have to kind of like listen to them, but also like kind of like convince them why what I want to do is sensible. And so after like writing a lot, like, you know, I made a lot of noise about it, like I talked to people about it, but what actually helped obviously was like results, right? And so I was able to like work with people to build an example of a much cheaper version of a Gaussian avatar. And then once I had that, like, people around the company were like, oh, like this looks great. Like, let's all just build up on top of like what Forrest and these people did. So I think it was kind of an exercise in hearing enough input from people to know what are the right problems, but then kind of tuning it out and just like trying things until you get a solution, and then bring all the people back and be like, okay, like we've got something for you. I think the trap with this is if you know too many people in an area in a company and you just let them talk at you all the time, you'll never have any time to do work. So yeah. Anyway, so this ended up being like, I think a pretty big breakthrough in the Gaussian spotting field. It was my first ever time trying to write a SIGGRAPH paper with many bright colleagues and mentors, which I'm sure all made all the difference. But it got in, you know, and I know a lot of people have been trying for a long time to do something like that, and so we were super lucky to make that much of a contribution.
And it's being used now.
Yeah, yeah. Well, I feel like the avatar thing is constantly being revised and refined, but it definitely was a brick in the wall. I think it might still be in the wall of progress.
So you said next year you want to come back and talk about what you're working on. What would you put as the problem on a sticky note for what you're going to talk about next year?
I would say fitness tracking from those devices.
Fitness tracking. Got it. If you were to step back again, I mean, you've been at Meta for a few years now. What would you do what would make you want to do another startup, and what would you do?
I think I have a couple ideas on that. One thing I like about Meta, and part of how I'm able to keep things reasonably fresh, is I'm able to just, you know, kind of within reason, whenever I want, kind of wrap up the current project or hand it off or delegate more of it and then try to start something new. And whether it's plugging into an existing thing that's taking off, or the fitness thing I'm going to show you next year if I come back is really quite a bit different. So I could show you that later. But I like the idea of just starting something new every year. And doing that in a startup works great. Doing that in a university works great. Or sorry, I back up. Doing it in Meta seems to work okay. Doing it in a university is great, right? Because there are semesters and semester projects and conferences that just have like deadlines once a year. So you can really pivot a lot if you want. I think one of the challenges with a startup is unless you really want to commit to that problem in the long term, it's hard to be able to jump around too much. And so to do another startup, I have to be really sure that I want to do this for, not just a big push for a year, but like, for 5 or 10 years. 5
or 10 years. So about 50% of the students in this class have said, at least last week they said, they're interested in doing a startup. Do you have thoughts for students as they're thinking about doing their own startup or going to a larger company that you could share, as you've done both?
It's a very broad question, but let me try to just pick a couple of, I could talk about almost anything. Let me just pick like a couple of things that might be good to know. One is, I think if you can fit in some of the activities that you would do as an entrepreneur during your school or over the summer or things like that, I think that's wise. You can get experience with building prototypes, which I think is faster than ever with all the AI tools that are out there. You can show potential customers and see if they're interested or willing to pay or pre-order it. Like, these are all things that may take a lot of mental energy to do and some energy to execute, but there's no reason you need to be a full-time job at first. So I would say the bar to start tinkering with that and looking for product ideas and product market fit is actually kind of low nowadays. The bar's pretty low. I would say in terms of, do I want to raise venture capital money and commit several years to this and either, leave school earlier than you'd planned or not do a different job that you wanted? That's where the friction really is, right? Yeah. Is making that choice. And I mean, I think one great thing about the US compared to some other countries' education systems is you can really live life in whatever order you want. You could do a PhD when you're 50, you could start community college at age 70, you could do a startup at age 12. Like, nobody really cares. It's not like there's like an entrance exam for the thing, and if you don't do it and pass, like, you're just done for life. So I wouldn't, like, you might worry about like losing your personal momentum to continue into the startup or to chase down that academic achievement or chase down that job achievement, but it's really all you, right? It's not really like society is imposing any constraints in what order you do this stuff in.
Yeah, I mean, in the spirit of not imposing constraints, I hope we'll have a lot of interesting questions from the group, and then we'll go until about 6:25 with questions, but I'll let you all start to think about questions. There are, and Bobby, and just so you know, Forrest, Bobby and Claire are going to be running around, hopefully getting lining people up. So when you ask a question, would you introduce yourself also? All right, first question. Faster, you guys, right there. We're really going to push you all on this. As soon as you ask your question, can you give your mic back to Bobby or to Claire so that we can line them up?
Awesome. Thank you.
It's the mechanical engineer, right?
I'm a mechanical engineer. Thank you for being here and
Braver than
thank
me.
you for sharing your story. You mentioned in the beginning of your talk that it's important to build your network. And I was wondering, how and where do you suggest finding the right people to build your network?
Can I back and forth? What have you tried so far?
Yes, you can.
Meeting students in my classes and going to events like these, but also joining teams and clubs where people have similar interests.
Yeah, I think that's good. I think it's a very personal answer. Like, I think if you can find hobbies or projects that you want to work on that personally interest you, there will be some magnetism around you and other people who want to do that. I think there are other people in the world who aren't me, but who just naturally connect with everyone really easily. For me, it's been much more about like, can I spend quality time with people working on, doesn't have to be like intensely working, but doing an activity that we enjoy. It could be making something or something else. So I think that helps a lot. And then just taking the time with those people to just like go take a walk and learn about their life a bit. I think knowing about other people's life, helps as well.
I see. Thank you so much.
Thanks. Next.
Yeah, hi, I'm Tom. Thank you so much for speaking. You spoke in your TED talk about creativity in AI, and about art in AI. And I did some work over the summer on poetry generation and found the one particular moment for me was I showed a poem to my nan that had been written by AI and she cried. And that was like a moment of like, oh, like this can really do something. Do you think that AI and creativity is a positive thing for society and it's going to add more beauty and more sort of positive stuff, or does it undermine our purpose?
I think it's pretty exciting. As someone who's terrible at drawing, I feel a little bit like I think people can still recognize typically when I have AI draw something for me, like I'm not passing it off as my own. I don't think anyone believes it is at this point. Maybe later they will.
Ooh, like what kind of prompts would you use? I'm just curious. Like how is your prompt when you want to draw something?
Just things like, here's a room or here's an object, like help me decorate it, right? Oh. Or here's a user interface for a product or a screen, like just draw me a picture of what it would approximately look like. And sometimes even then I take that and feed it to another LLM and say like, code this for me, and it works-ish. But I would say it's just like, for me it's like this big weight has lifted. Like I don't have to be good at everything or always have to be finding people to ask for help with some of these visual arts things. I can just kind of make some progress through it. I can't sing it, but I can at least hum it, when I'm trying to think of a song. Like that would be a good analogy of how this works for me.
Yeah. Did you tell your nan that it was AI? Yeah. All right. Next. Yeah?
Hi, my name's Aaliyah, and I transferred to, first of all, thank you for being here. This has been very interesting. And I wanted to go back on something that you mentioned at the very beginning of the talk. You talked about California as being a place where people are consistently aggressively pursuing some goal. And so I just transferred to Berkeley earlier this year, and that's something that I also very much noticed. But I also find that it's pretty easy to lose track a little bit of why you came here in the first place, because it can be very easy to get distracted by what other people are doing, which is also really cool, or to find
FOMO, right?
Yeah, and to find that the competitiveness can be hard sometimes. So my question would be, what advice would you have to just stay focused and stay on track?
When I was in high school, I was a cross-country runner, and I was okay. Like, I wasn't the best on our school's team or the worst. And you think of sports as something you go to other schools and compete, but really, these other schools, I don't know any of these people, but the people on our own team, we're all running the same race together. We're kind of competing with each other too. And so, like, I know, like, okay, like, I'm faster than Cliff, but I'm slower than John. Like that's how it's been in practice. So that's what I think ought to happen. And suddenly, like, I'm just gauging myself based on the other people. I'm not really tracking exactly what my time is. And there was one race where I was falling, kind of falling or no, there's one race where I was like really trying to keep up with someone else who was doing way better than normal. And the coach actually saw me when I was going by, and she asked, like, Forrest, like, you're not gonna make it at this speed. Whose race are you running? Like, she yells these like 6 words, and I point at myself, and I like slow down, and then I probably saved myself from just having to stop halfway through. And so just maybe when you talk to other people and reflect on your life, like at dinner or things like that, and you talk about, like, I'm stressed because everybody's doing X, or so-and-so's doing X, or, you can kind of maybe chat with other people and kind of unwind that and start to figure out, but like out of all these different activities, what actually is important to me and what can I sort of let it go? But I think, like, by asking the question, you basically are halfway to solving the problem, right? Like, that comparison with other people below, like, a little bit of it is helpful for staying motivated, but too much of it is kind of toxic.
I like that. Whose race are you running? Who's got the bike? Introduce yourself. Yeah.
Hi, I'm Zida. I'm from Italy studying robotics. Actually, the question I have is about what are your thoughts on how we close the gap on training real robots, like, for example, can be autonomous robots to do our domestic problems, or surgical robots. So far we have only data, a lot of data being trained on AI models, but how we close the gap to train also robots like real robots.
Yeah, I mean, an interesting conundrum in AI is that text-based AI and visual, AI that runs on a computer screen has turned out to be a pretty, we can solve a lot of things there with our current technology. But embodied AI, even to do things that we consider as humans to be relatively unskilled labor, like screwing in a light bulb or washing the dishes, has turned out to be incredibly skilled labor, maybe beyond the level of skills that this AI labor currently has. And in terms of solving that, I'm really not sure. My boring answer is I've decided not to go super deep on that right now because I feel it's pretty early. Like, I think there will be a lot of trial and error before it starts to kind of, hit the real hockey stick growth. But it is cool that we're in a phase where a lot of people are experimenting and there's more hardware available than ever, and like progress is being made.
I love that you answer, I'm not sure. Yeah. It's a good answer. Next.
Hi, I'm Stefan. I'm a freshman majoring in data science. And I was wondering, like, what's an area or field that you haven't immersed yourself in yet that you might potentially want to work on in the future?
I still want to be a car engineer sometime. I might be when I'm retired.
Can you tell us a little bit about your racing?
Sure, yeah. So I've always been into cars, but one thing I picked up at Tesla was obsession with electric cars. And so I've also wanted to go racing for a long time. And when I finally had a reasonable amount of time and money to do it, I put together an electric race car. You can go to the slide if you want.
Yeah.
And I've been running it in a series that mostly has gas cars, but they allow EVs. So this has been a good outlet for at least tinkering with some basics of how to improve car software and understanding the guts of how an EV works. And the further I delve into it and improve things, the more I learn. I think compared to working in AI and software, this is a kind of like the vehicle space is a bit slower moving, a bit less profitable for most people involved, but it's still something I'm very passionate about and would love to work on all day, every day at some point in my life.
So, the person was talking about naming food. That's what they want to do. I'm wondering if you have a car name.
The team is called Electric Turtle. Turtle because, like, we're painfully self-aware of how slow we are at doing this.
But that's still interesting. Next.
Hi, my name's Napoon, and thank
You
for,
guys in the back row, raise your hands too. Yeah, sorry, go ahead.
thank you for your talk. And after running a successful startup, what are like some good first principles you've kind of learned from that experience of starting a startup?
If you don't mind my asking, where are you in the school and what's your background?
Yeah, so I just transferred here and I started kind of a startup in the legal tech space and just had some early users and getting feedback on product.
That's great. I mean, I think you're already doing some of the things that you need to be doing. I think understanding your customer problems early, building things that ultimately, well, it depends what your goal is, right? If you want more of a lifestyle business with like a smaller audience that's really true to like the product that you personally want, that's a totally valid direction that I feel doesn't get enough credit and maybe doesn't get enough respect in the Valley just because it's not like aligned with what investors want. But if you want to build like $1 billion company or a very large successful company or get like, you know, acquired in the right place at the right time, I think spending a lot of your mental energy trying to figure out what are things in the, like, I think, is it Paul Graham who just like, he's like, I'm writing all these blog posts, and he's like, I know, build something people want. You're like, that's like kind of all there, that's like kind of the sticky note, right? So it sounds simple, but you know, figuring out whether people will pay for this and to what extent they'll use it and what are the alternatives and what's the competition, you know, there's a lot there. I guess another just like quick thing I could say is I think you're much more likely to fail due to kind of like lack of customers or lack of product market fit rather than too much competition. So I wouldn't be too scared of going into a space that feels like a little bit crowded or a little bit busy, as long as you can identify something that you really think people want and you can figure out how to build it.
Nice.
Hi, I'm Mirsad, and I had
do
two
you see where he is?
questions. Yeah, here.
Oh, good, thank goodness.
Yeah. Yeah, first question about your PhD. You mentioned one of the benefits of doing a PhD was the fact that you could figure out which questions to work on. Was that the result of being around a lot of people doing similar research, or like how does that how do PhD help in that way? And then the second question is, at the current stage of world models, do you believe that using world models could be a good source for training, as someone mentioned, robots, or basically VLAs for robots?
Good question. So I think finding topics to work on, I think you can use the PhD for a lot of different things, right? You could use it to just explore something you're interested in, as long as you can kind of get on the same page with your advisor about it. You know, if it's something you're interested in that not a lot of other people are interested in, that's still a totally valid thing to do for your PhD. It may not be as helpful for building a really successful startup, or maybe not successful is not the right word, a really profitable startup, or finding that really profitable job, but it may be very satisfying to you personally. I think a lot of people, including me, try to use the PhD to work on problems where if we can solve them, there are a lot of people who will benefit, and maybe it will also help us or other people build products. And from that mindset, I spent a lot of time looking at in AI, what are the benchmarks, what are the tasks, what are the models that a lot of other people are working with? And if I can swoop in and give them a better model or a better way to evaluate a model or a more efficient model that a bunch of people would use it, then it would be kind of like a thing they plug into their research work. They probably cite our paper, which has some value for an academic career. And it would really be something people pay attention to rather than something that just kind of stays on the fringe. So that's really what I aimed for, but the fact that you can use it for so many things, I think, is nice. On world models and VLAs, I think the correct answer on Twitter is yes, but personally I have no idea.
Wait, on X, you mean?
X, yeah.
I don't.
Yeah, maybe
I
on Salem
apologize.
too
I
also.
need the translation for VLA.
It's a vision language action model, so it's
Okay.
sort of like a large language model, but it can also look at visual data and it can also produce robot motion and output.
Thank you.
Hi, thank you so much for speaking with us today. My name's Tiffany. I'm a first year, and I was just really interested in like seeing all the different projects you were involved with, and I was just wondering like what inspires you or makes you want to like wake up in the morning and get ready for the day.
Well, there's maybe two answers to that. The simple answer is I actually am not great at the whole getting up on time thing, and I feel like no matter what I do, I just go to bed 8 hours before the next meeting. Sometimes I got to get better at that. So like if the next meet, if I have a meeting at 10:30, then I may stay up as late as like 2, right? And my body really would rather sleep or rather have like a 25 or 26 hour day. So I'm actually pretty bad at getting up on time. But to maybe the spirit of your question, why do I show up for work, or why don't I just do something silly and not do this? I think in our heads, we all have several different characters. I think it's a little bit stigmatized to say you have multiple voices in your head, but that might be actually a good way to say it. And you probably, if you listen carefully to yourself, you have a voice that's focused on ambition. You have one that's focused more on family. You have one that's focused on solving problems that you think are cool. You have one that's focused on camaraderie and enjoying working with others. And for me, it's kind of partially about keeping these different characters in my head happy and giving them something to chew on. And so I think they're all easily bored as well. And so I think, some combination, some compromise of achievement, camaraderie, feeling of discovery, novelty, all these things. There are a lot of different activities I could do that would satisfy me, and there are also a lot of activities I could do that would be unsatisfying under that lens.
That's great. I think we have time for about 3 more questions, and then I'll post our attendance link. Can we go all the way in the back? I don't know if 2 people have the microphone, but then can we go all the way in the back? Is that Star? Is that you? Yeah. Okay, who's got the microphone next?
Hi, my name is Vina. I'm a junior, and I'm over here.
Yeah, thank you.
Hi. Hi, my name is Vina. I'm a junior and a CS major. I'm generally really excited about ML and robotics research. And I guess my question is, considering all these various topics in ML, like reinforcement learning, like theory, vision, I guess where do you think the most exciting areas are to work on? And like, where do you think engineers can make the most impact?
I think there's definitely a unification of models, right? Like it used to be 10 years ago, there were vision people and natural language processing people and speech people, and now people are merging a lot more stuff into one model. And I think in industry, in a lot of companies, you have the opportunity to build those models, sometimes maybe taking existing ones and modifying them or fine-tuning them to do new things. Sometimes, depending on the situation, maybe even building them completely from scratch. I think these are all good things to get some experience on when you get the chance. I think one challenge is in an academic environment, even in a very well-funded PhD lab, you often will have like 1/1,000,000th the amount of compute you would need to build one of these from scratch. And so the challenge is, how do you make some progress? How do you derive some new insight or some novel understanding or some better result without having the compute to produce a new one of these models or even to customize it very much? And I think that definitely challenges our creativity. I think finding applications that everyone else isn't doing can be good. I think also building new ways of evaluating the models or new ways of connecting the models tends to be good as well. But I think outside of the kind of frontier labs, as they're called, that build these things from scratch, viewing this in a similar way as people will view other kind of pre-existing programming tools, viewing these models as just existing programming tools to build something with, may be more productive than saying I have to invent the next, like one of the models that you mentioned.
It's great. 2 more questions. Who's got the mic?
I have the mic.
Okay.
Hi, my name is Rihanna, and I'm majoring in computer science, astrophysics, and cognitive science. And I had a question for you. So my question is, do you think AI will ever have a consciousness?
I kind of wonder will we ever really understand how human consciousness works? I don't actually know if a cat has consciousness or an insect or a plant. So I actually feel like over the next year, the scientific community may make much more progress in improving AI than actually understanding what is consciousness. But I didn't major in cognitive science, so if you know what is consciousness, spit it out.
Do you have any thoughts?
Well, I think there's still so much of the brain that we don't understand, which is why I asked you that question. I just wanted to see what your thoughts and what it would be in the future, like based on all the research that, and all the AI that's evolving right now and all the studies and research in computer science. So,
It would certainly be exciting if it does.
for sure.
Last question. And then we'll have the last question, but Forrest, you'll be here for a few minutes, so you can approach Forrest on stage too.
Yeah, I'll be here. There's
Yeah.
a microphone in the
Okay, yeah,
back.
sorry. Hi, Forrest. Thank you so much for coming back to Berkeley to speak with us again today. My name is Star, and I'm a psychology major, 4th year. And to the extent that you're able to actually speak about it, for patient-centered care driven by wearables and health data, what are the biggest privacy and interoperability challenges, and how do latency limits, similar to those like that you experience with VR and avatar systems, like how does that constrain real-world development?
Are you just kind of asking, like, what are the privacy constraints? Like, what's the difference between what we could build with no privacy constraints versus privacy constraints, or what?
I think I'm more interested in like the latency limits of, for example, health data and trying to work with the cloud and like edge or mist computing and
Yeah, I guess I'll preface this with I'm not a privacy expert. Like in my job at Meta, we have a bunch of legal experts who I kind of run a lot of things by, and they tell me like thumbs up, thumbs down on whether I can do it. So I'm not really in the driver's seat of deciding a lot of that. But what I can say is I think a bias towards edge computing is certainly good for privacy. Like if the data that's specific to you can more stay on your devices and maybe just the summary of that data goes to the cloud, that probably creates less risks of your data being maybe getting in the wrong hands than if it were a purely cloud-based solution. This is just a general thing. It doesn't matter if you're doing security cameras, fitness, health, personal assistant, like all of them have these considerations. But you probably already knew that. So if there's a deeper question you're asking, you can tell me.
Well, you can do it one-on-one later.
Okay,
but
sounds good.
I just wanted to thank you for sharing so much about what you privately think, what you've been doing business-wise. It's an incredible way for us to start the semester because you're also within 10 years out of school. And it'll be exciting to see what you have next year. And it's been great to have you here today. So a huge round of applause and a thank you. So, Forrest, what we do is we have an attendance and enrollment link with feedback. I'll give you feedback. I would love it if the person who's also taking a photo can take a picture of the two of us. And then once you all have given your feedback, I'd say come on up if you have questions for Forrest. That would be great. Thank you very much, Forrest.